Well, this weekly test was rather special. I think a lot of you are perhaps oversaturated with the amount of information that you need to know. Still, I'm a little bit disappointed in some of the questions. This first question over here, although there is aspects of stereochemistry that's involved on adding to ketones and cyclohexane rings, it really doesn't need any of that knowledge. This is just a Grignard reaction. So phenyl magnesium bromide would have been absolutely fine to answer. It's really simple. But many of you also added acid. Well, if you did that, the reaction wouldn't work. It would just go to pot. It's useless. You do need to do this in 2 steps if you do that. This one was a little bit harder. The reaction is not going to work with sodium borohydride or lithium aluminium hydride because they're small nucleophiles, and if you do work this out, this must be equatorial up. So that means that over here in this product, this OH is axial up, and it can only be axial up if the nucleophile that went in was large, and the only option is to use a large reducing reagent, which I did in class yesterday. So the 2 options are something like lithium aluminium hydride, but the tertiary-butoxy lithium aluminium hydride, or another option would have been the sodium borohydride version, which has the tri-sec-butyl. So bulky reducing agents, and that would have worked. A stable chair conformation, again, some of you got it right, but mostly okay, I guess. You just need to draw it out, get your chair structure, and then just fit in the substituents. Some of you drew the enantiomer because you went round the wrong way, but essentially this is where a lot of you did it and it was fine. So just put these in. A lot of you got this ethyl group incorrect. It has to be parallel to this line here, like that. Go around, and then we've got the isopropyl group. Okay, there's no wedges, no dashes, no anything like this. And all these big groups are now equatorial, so it's the most stable. And then to finish off, we just had some simple reactions. MCPBA oxidizers, I did it in class yesterday. If you weren't there, you clearly didn't know what was going on. And so it just forms an epoxide. The important thing though is because this is a bicyclic and the 2 hydrogens are pointing up, this whole thing has like it's kind of curved shape. The underside is blocked. The top face is available. So the hydrogens don't change, they're there still, and but the epoxide is on the top face. So you need to show that. If you didn't show stereochemistry, even though you put the epoxide, you didn't get any marks. So you need to show that the epoxide came on the top face. And this one brings us back to our enolate chemistry. LDA, it's a sterically bulky base. It's going to form the enolate, but at the least sterically hindered side, so it's over here. And then our electrophile comes in, and now we need to just choose which face the electrophile comes in. It's the benzyl group. And again, the benzyl group comes in from the least sterically hindered face, which is actually the bottom face, because the hydrogen is pointing to the back. The 6 and 5 membered ring is up like that. So it's the underneath face which is actually the most accessible. So if we draw it out, the benzyl group ends up down. So we'll have the ketone there. This is just the chemistry that we've done already. Okay, so that was the answers for weekly test, or my 4th weekly test I gave you.